All right, second one here. So I'm trying to change it up. Involves a rectangle. So we have in this picture, angle EBC is congruent to ECB. EBC, ECB. We also have FE is congruent to GE. We need to, and we have BA is perpendicular to AD. So again, perpendicular means right angles. So BA perpendicular to AD and CD perpendicular to AD, another right angle. CD, AD. So I got two right angles. So now I have to prove that ABCD is a rectangle. So I'm thinking this should be a piece of cake, right? Well, I don't know that ABCD is a parallelogram. If I know that ABCD is a parallelogram, then having one right angle is good enough, okay? So I have no idea about this angle here and this angle here. If they were right angles, that'd be great, but I'm not sure. So if I'm looking at this picture, right? So I have an isosceles triangle here, an isosceles triangle here. So that could be helpful. Okay. And now I'm looking at what else I could do. So I think I just figured it out. Goodness gracious, here we go. Okay, bear with me. So these two isosceles triangles, right? So we know that these two angles will be vertical. So say that each of those is what, 100. Well, that means this would be 40 and 40. And these would have to be 40 and 40 because they're both isosceles triangle, which means that this angle and this angle would be congruent. And that would mean that this line and this line would be parallel because they're alternate to your angles. See the Z? See the Z? And if those lines are parallel, then that means that these two angles must be supplementary. So if that's 90, this is 90. And these two angles must be supplementary. If that's 90, that's 90. And there, I think, is our proof that it's a 4 right angles. So that's the way I'm going to approach it. Okay, let's see if I can find the reasons to get that done. All right. So again, a couple things from the given. Let's go with the right angles first to establish my two right angles. So here, because BA and AD are perpendicular, I know that angle A is a right angle. Let's start there. Perpendicular lines. I know that angle D is a right angle. Perpendicular lines. Okay, so now let's go on to this whole isosceles triangle thing. So FE and GE are congruent. So now I know that these two angles, let's call them EFG and FGE, are congruent. And that's because of the isosceles triangle theorem. If two sides are congruent, then two angles are congruent. Okay. All right. And now, so how am I going to connect these two? Well, let's go with these two angles being vertical. All right, let's see how this plays out. So we'll say angle BEC is congruent to angle FEG, and that's because they're vertical angles being congruent. So now I wonder how I can do this one. So let's just see if they'll let me say that angle EFG is congruent to angle ECB. Let's see. What do they got for me? So no, and it's no. I'm looking for something about if two angles of one triangle are congruent to two angles of another triangle, then the third angle pair. No. So I wonder how I'm going to get this done. Let me pause and take another look at it. So here's the route I'm going to try. I'm going to try to say that they're isosceles triangles. So we already know that EFG is isosceles. Let's go ahead and say that EBC is going to be isosceles, but let's first say that we have these opposite sides being congruent. So EB and EC are congruent because if you have congruent angles, you have congruent sides. So we have two isosceles triangles. So classified triangle. So EFG is isosceles because we have two congruent sides. That's fine. And then EBC is isosceles because we have two congruent sides. Sure. Okay. So now let's see if we can prove that these angles are congruent. Let's see if we can prove that angle, again, EFG is congruent to angle ECB. Let's see if anything opened up about isosceles triangles. Nope, that's still all I got. That's a bummer because I think we're gonna have to say that they're similar, probably. So I was thinking I had to do similar triangles, but maybe not. Okay, let me pause it. And I discovered it. Okay, here's what we're gonna do. All right, so again, these are hard. All right, that's what makes them so much fun. We're gonna use this triangle, right? We know that this is a right angle. We know that this angle is congruent. So we should be able to find this angle. Well, same thing over here. This triangle. Same angle, same angle. We'll know these. So these two angles right here and here will be congruent. Okay? So that's our next statement. So I'm going to say, so again, I did not need the isosceles triangle. That was me reaching. So I now know that angle ABG is congruent to angle DCF. And this is called the third angles theorem. So in each triangle, we have two sets of congruent angles. So if two angles are congruent, then the third must also be congruent. Are you kidding me? Oh, okay. So we haven't said the right angle. I'm sorry. We haven't said the right angles are congruent yet. So angle A is congruent to angle D. All right angles are congruent. Sorry. Okay. So now we have those congruent. Okay. So now we can say, again, semantics, that angle ABG is congruent to angle DCF. And this is the two angles congruent. Then the third angles are congruent. Okay, good. So now we can say that angle ABC and DCB are congruent because they're made up of congruent angles. So now we can say that angle ABC and angle DCB are congruent because if you add congruent angles, you get more congruent angles. Okay. Well, from the very beginning, if angle A and angle D were right angles, then that means that segments AB and DC are parallel because angle A and angle D would be same side interior angles and they add up to 180. They're supplementary. So I have parallel lines. AB and CD are parallel because I have same side interior angles being supplementary. Oh, so I haven't proved that they're supplementary yet. So I need to make sure I say that. I love how this tells me what I have to do. So angle A and angle D are supplementary. And again, it's because they add to 180. If two angles, I just want to say they're two angles that add up to 180. Right? They're both right angles. So why are they supplementary? Because they're both right angles. Not a linear pair. They don't form a right angle. They're not. They're not of those. What? Man, oh man. I'm upset about this. They should have this in here. All right, so I got to kind of switch gears. So now I'm going to show why they're parallel. So I'm going to mention that AB. So in here, see how AD is perpendicular to both AB and CD? There's a theorem that says if two lines are perpendicular to the same line, then they're parallel to each other. So we're going to say that AB is parallel to CD, and it's this reason right here. Two lines perpendicular to the same line. Okay, so I've shown those two sides are parallel. So now I can say that angles ABC and DCB are not congruent, that they are supplementary. Angle ABC and angle DCB are supplementary. And that's because you have parallel lines cut by transversal, same side and triangles are supplementary. But we also said that they're congruent up here. So if two angles are supplementary and congruent, then they're each a right angle. So angle ABC is a right angle because it is supplementary and congruent to angles, and so is DCB is a right angle. And we have four right angles, and that what makes ABCD a rectangle. So ABCD is a rectangle because it is a quadrilateral. I know nothing else. It's a quadrilateral with four right angles. I did it. Took me 16 steps. I'll be interested to see what they did. Some of my steps were useless, right? So they did theirs in 12. Again, I don't need the isosceles triangles. Let's see what they did if they used my same idea. So they did that. So they did congruent segments. They did those angles. We did that. They did the right angle. They did the right angle. So the right angles are congruent. Okay, so they proved these two triangles congruent, you see? Okay, so good for them that they're sticking with that congruent triangle theme. And they did the opposite sides there. They did the perpendicular lines to the same line. That's fine. So then they called it a parallelogram because you had one pair of sides congruent and parallel. And then they said it's a rectangle and had one right angle. So again, that's how they did theirs. I did mine that way. So that was a long proof. Sorry, I had to keep pausing. But again, there's always a way. One more coming.